Back to chapter 2. We're talking about variance and standard deviation. Now this is another measure of spread of our data. We've learned about the range and the interquartile range. We know that the range is a non-resistant measure of spread because it's affected greatly by outliers or data values that go outside the bulk of our data, so to speak. And we learned that the interquartile range was resistant because it was the middle half of our data. Well, we're going to find that variance and standard deviation is also a non-resistant measure of spread because it depends on the mean. So what the standard deviation and variance gives us, or standard deviation, is the average distance each data value is from the mean, or what we would expect the value of our distribution to be. So with that being said, if all our data values were the same, 3, 3, 3, 3, 3, 3, 3, our mean would be 3. So there would be no variance in our data. So the greater the differences are, the greater our variance and standard deviation is. Now variance is the squared average distance of each of our data values from the mean. So here is what we're talking about. Variance is based on the deviation from the mean. So each of our data values minus what the mean is, or what a typical value is. And of course we have it different for, the symbols for population and sample. Xi minus mu is just a single sample value minus the population mean. Whereas just below that you see Xi minus X bar, that's for samples. Now the problem is, since our mean is that arithmetic middle point, that fulcrum, so to speak, we have as many values to the right of the mean as there are to the left. So if we do this, Xi minus mu, or Xi minus X bar, and we add them all up together, we're going to get 0. Let's take a look at what I mean. Let's look at the data in column C7. I'm going to get the mean of that column. It's 4. So in C8, I'm going to have the difference between each of those data values in C7 and this new mean that we found, the mean, which is 4. So the way I do this, I would say let C8 equal C7, all the values in C7, minus that mean that we just calculated, which was 4. Now let's look at the sum of column 8, the sum of those differences. It's always going to be 0. So we have to find some way to get rid of that negative. And so what we do, we could do absolute value. That's one way to do it. What we do for our problem is we square those differences. So we take C8 and we square it. So we say let C9 equal C8 times C8. And now we could take the sum of those differences and get the average of those, and that's what's called variance. So for the population variance, you take all those differences, you square them, you add them together and divide by n. However, for the sample variance, you don't divide by little n, you divide by n minus 1. We say that this statistic has n minus 1 degrees of freedom. So please look on page 51 for an explanation of the n minus 1, the degrees of freedom. So let's see how to use Minitab to help us calculate sample standard deviation. Well, we've already seen it so far. We had our data in this column, if you remember. And then in C8, that was our data, I should call it data 1, or data 2. So column 2 was our data minus the mean. And the last column is the data minus the mean squared. And now we can sum those that column using this command, sum C9 that we've seen before. Hit enter, and now we have the sum. And to find the variance, the sample variance, we'd say, let's do our constant again. Let's say K3, that K3 equal 26 divided by n minus 1. There are 4 data points, so we're going to divide by 3. Print K3, and there we have the variance. Now some of the homework asks for the sum of the squares. Well, we have the sum of the squares. Just before we did the K3, when we did the sum, when we said the sum of the data, it was 26, that's the sum of the squares. This now, K3 is the variance. And to do the standard deviation, we'd say, let K4 equal the square root of K3. Print it. Oops. Print K4, and there you have the standard deviation. And that's how you use Minitab to help you to get the standard deviation. If you had to show step by step what you needed. Other than that, what you can do is very easily, if you wanted to calculate the mean and standard deviation, is just hit your describe command. Describe where the data is, it's in C7, and it will give you the mean, which we got as 4, and the standard deviation right here as 2.94. If you wanted more decimal places, you could say standard deviation of C7. And there you have the standard deviation in more decimal places. And if you wanted variance, you could just square that value. So as you see, the standard deviation is just the square root of the variance. The population standard deviation is the square root of the population variance. Population variance is sigma squared. And so population standard deviation is represented by sigma. Sample standard deviation is the square root of the sample variance, s squared. So that means that standard deviation, the sample standard deviation, is represented by s. And now when you do these calculations by hand, do them like in Minitab so that it holds those decimal places for you. Otherwise, if you're going to write it on paper, you've got to write out many, many decimal places or you'll have rounding error. So I would prefer that you do it in Minitab when they ask for those questions because, of course, on our tests, you will not be required to calculate standard deviation. So to answer some questions, what is a typical deviation from the mean? It's what we're going to call the standard deviation. Small values, generally small values in this deviation indicate small variability in your data. And of course, large values of this typically denote that there's large variability in your data. Now the next couple of slides will be examples of calculating the mean also. So please look at those. But I suggest that you do, just because that's exactly what we did in Minitab, that you do it in Minitab, and therefore you won't have to worry about rounding error. But there's great examples of that. Now choosing a measure of center and spread, well, outliers affect the values of the mean and standard deviation, so if you have that, or you have skewed data, your 5-number summary should be used to describe the center and spread. Now you use the mean and standard deviation if your distribution is reasonably symmetric. So here's some data here. We did the 5-number summary of this book data. And when we draw the picture of the box plot, we see that we have a very skewed data. And so the best measure would be your 5-measure summary. So your median being 3 and your interquartile range being 4.5. Look at the difference between the mean if you calculated the same data with the mean and standard deviation. Now here's that describe command, and again, very important to remember is that Minitab will give you different Q1s and Q3s than what we do by hand. Now just by looking at the median and the mean, you would say with the differential of their values, you would say that the data is right skewed because the mean is so much greater than the median. And again, by looking at this box plot, just by looking at that, you would say that you have right skewed data. So again, as I said, your best measure would be the interquartile range and the median.